Hello, Python Basic people. I'm grateful for those who wrote in the well-being file. I read it. So I want to reflect a bit on it, and also I want to really invite all those who did not write, just maybe during lunch break or at some point, write this one sentence about yesterday, the hard thing and the good thing, because it also makes us easier to follow where are you, and also afterwards it might help you see where you at certain points, because otherwise you might just forget everything what happens. So one of the things that several of you wrote is that you are, what was the name, overwhelmed, or the pace is too fast and similar. And so I want to say that it was expected that it will be intense and intensive, right? So, but on the other hand, it should be intense on your head, but it should not weigh on your soul. You should not feel desperate, okay? So please do not be in despair state. So what can I say you as tips? As a teacher, I know the situation when I want to cover the whole topic, but sometimes when I'm in the shoes of the student, I feel like, oh, it's too much. And then what I do, I just raise my hand and ask stupid questions. So if you have a question, maybe somebody else has a question. And it also helps to slow down a bit the pace. I know teacher will be frustrated, but it's for you basically. It's not for teacher, right? Also, we have two assistants, Sergei and Katrina, right? So those of you who were writing that at some point I just were lost. I could not follow anymore because I lost some step in the middle. If it's at your mental state and you just want to have a rest, that's fine. Just sit at your table and rest. But if you want to follow along, that's the time you address the assistant and say, oh, I need help, because they are here exactly for this reason. It's not that you are bothering them. That's why they are here. And when you are not asking for help, they are just sitting and feeling lonely, okay? So, with that, I give mic back to Uldis and have a good day.
Okay, thank you. So let's continue, and I hope it will not be that difficult or intense as it was yesterday. But the good thing is that yesterday we covered introduction to Python, so that you should be able to follow along, or even if there are some parts of the workshops that we have to skip to go slower today, you should be able to follow them on your own. You now know how to use Google Colab, how to run code in Google Colab, and I hope that you can follow along as well. But indeed, if you have any issues at all, raise your hand, and one of the assistants will help you right away. Now, I wanted to ask one question before we start. Is everyone able to run Google Colab today? Some people reported that Google Colab doesn't work for you, so for some reason. So if Google Colab doesn't work for you, then raise your hand now. So there's one person there. Anyone else? Okay, so for most of you, Google Colab works. And if Google Colab doesn't work, there is an option also to install the Anaconda installation, which has Jupyter Notebook inside it. Okay, so two people who have it. All right, can I have my notebook on the big screen? Okay, thank you. So the first thing that we will do today is we'll work through the Introduction to Natural Language Toolkit Jupyter Notebook. So go to the GitHub address, Notebooks folder, and download NLTK Introduction Notebook. This is the notebook. So I'll leave the instructions on the screen just for a bit. Today, in the first part of the workshop, we will look at NLTK, which is a powerful library for processing natural language text. So, everyone with me so far? Or you can't find the notebook? So you are on GitHub in the notebooks folder, and you don't have day 2 NLTK introduction notebook?
No, I have day 1 NLTK introduction, and I have day 1 day 1 templates.
So you have cloned it from Git, right?
Oh, I see it now.
Okay. All right. So once you have the NLTK introduction notebook ready, we can proceed. Again, if there are any issues, let us know. Okay.
I suggest showing the GitHub and showing how to download it and upload it again. Many people are having now difficulty following along.
Okay. So let's look at the GitHub page. The GitHub link is in your document preparing for workshops. So preparing for workshops document has a link to GitHub right here. Once you get to the GitHub page, click the Notebooks folder. In the Notebooks folder, click Day 2, NLTK Introduction, IPython Notebook. Click on it. Download this, click the icon for downloading the raw file. That will download the notebook to your computer. And then, when you run Google Colab, choose the option to upload a file, and then drag the file you downloaded into this window. Or you can browse and file the file you downloaded. So you should then have Day 2 NLTK introduction notebook working. So who else could not get this running? Raise your hands. So there's one hand there, and also you have.
Well, I can open the notebook, but I have no runtime.
You have no runtime. Okay. We'll look for a solution. That's a difficult problem to solve, but hopefully there is a solution. So who has not yet got Google Colab running? How do you know if it's running? That's a good question. You can create a new cell in this notebook. I will create a new code cell and just execute a print command in that cell. And if the print command prints hello NLTK in my case, then you know that your notebook is running. So it can execute code. It's not running. Okay, I will. Let's continue. Technical problems persist for some of you, but we have to move forward as well. So we'll try to solve the technical problems for those of you who have them. Just if it's not solved yet, raise your hand so that we know that you have issues that need to be resolved. Okay, but for those who are who have Jupyter Notebook, well, Google Colab running, let's continue. So first, to use a library, we have to import it in Python. Let's import Natural Language Toolkit, NLTK, and let's import also a library for data processing called Pandas. So let's execute this cell here. And I hope it works. Yes, it does work. Now, this material that I'm showing you is based on the NLTK book. So there is the NLTK library, and the NLTK library has a book covering its functionality. So this is a web page for Natural Language Processing with Python book, which you can access from this NLTK book link in the Google Colab notebook. We won't be able to cover all of NLTK today. It's just too large, but I will give you kind of start to introduction to NLTK so that you can explore it on your own and see what functionality you need. So that's it about the book. Now I have imported NLTK, and let's check NLTK version. NLTK has a class or provides an object called text that is simple helper for loading and exploring text content. So you can interactively work with some text using this nltk.text thing. And first, let's create a list of words, just a simple, sentence or a sequence of words. And by writing nltk.text and supplying words or our sentence as a parameter to it, we create this nltk.text object. So let's store it in a variable called myText. The type of myText is nltk.text object. And now, so is everyone able to follow?
No.
No.
No, because I downloaded.
Yes.
Imported the NLTK and Pandas, adding the import function. Okay. But then I can see where you are.
So I'm just a bit further under the heading nltk.text.
But I don't see in the file.
Okay, let me check. Okay. So let's continue with NLTK introduction. So we created this myText object, which contains text inside it. And let's look at various things we can do with this NLTK text object. For example, we can call a method count. So we write myText variable, which contains NLTK text object, and we call a method count. So myText is the text that I loaded into NLTK, and count is a method that NLTK allows us to run, basically like a function that we can run on this text. For example, let's count how many times the word example appears in this text. And it appears 2 times. Count searches for full words or full tokens. So if I would search for exam, which is just a part of the word example, we won't find any. Also, if we check if exam is in myText, it's not, but word example is in myText, so it will be true. Now, if we have a sentence, paragraph, longer text, just a bunch of text, then we need to tokenize that text. split it into words or tokens, and then we can form this text object on the resulting list of words. Yes?
But how can, like, if the exam is a part of the example world, and I would love to find, like, obviously example is the word with no other endings, but there can be a word with different endings, and I would love to use this exam as a core, but it's not finding anything. How can, yesterday you showed us that we can have a half of the word and it will find all the variations of that word. Now it is not finding anything. How can we, why is it so, and how can we change it?
How can we find variations of the word? Well, one way to do it would be to normalize text, to convert all these words to their normal form, either by dropping suffixes, stemming them, or by lemmatizing them, so converting them to their basic form. That's one way to do it.
Why isn't it finding example when I write exam? Because it's a different complete word.
It's a different complete word.
But if we would write example, then it would find example or not?
No, it doesn't matter. It doesn't matter if if exam is a word, but it's just different from example. In this NLTK text object, it's looking for whole words. So if we have just exam, it's not finding it. How we could find all the words that have exam as a start? That's a good question. Maybe we can look at it in this. I can go to you and see how we can do that in the third part of today's workshop, just so that we can move on now. But do remember that question, and the third part of the workshop will be where you work on your own with our help, of course, and there we can solve things like this. So, to work with arbitrary text in this NLTK text form, we need to tokenize the text. For that, we need to, this tokenizer that we will use uses the punct tokenization model, which we need to download. Well, you only need to know that you need to write nltk.download punct. And now we can import word tokenizer from NLTK tokenize. Here is an excerpt, just some text that we will work with. Of course, the text could also be much longer and it could be imported from a file. I will show how to do that as well. And let's split the word into tokens. So NLTK has been called, this also gets transformed to a token, and so on. And the type of tokens is a list. So basically we get a list of tokens, which is stored in the tokens variable. And then we build nltk.text object based on these tokens. And then we can count, for example, how many times the word NLTK appears in this text. Or we can look at first 10 tokens inside this text. Now, NLTK comes with a number of language resources, including corpora, that we can work with. I will use these language resources as a demonstration. So to download all the language resources that are mentioned in NLTK book, we write nltk.download book. And you can see that quite many resources get downloaded. We won't use them all, but it's good to have them available. And then, once they are downloaded, we can run command from nltk.book import everything. That will import texts, text 1 to text 9, which are different, corporate different texts, such as Moby Dick or inaugural address corpus from the United States, or Monty Python and the Holy Grail, if you wish. First, once we have imported them, we can look at the list of what texts we have available, and it just prints the same thing you saw before. We have text 1 to text 9 variables available to us. If we now consider variable text 1, which contains the text of Moby Dick, let's check its type, and its type should be nltk.text. So what you already saw before. Are there any questions or issues?
What is it, a question? Why does it say nltk.text.text?
Why does it say nltk.text.text? I did not go into these technical details before, but basically it says that inside the NLTK library is a sub-package called text, and that text contains a class called text again with capital letter T. So it's just the way how this NLTK library is structured. Thank you. And now we can count the number of mentions of whale in Moby Dick, which is 906 times. We can also look at concordance that gives us context of a given word or a phrase inside the text. And to get concordance of some word, we just write the name of the text of a variable containing NLTK text object dot concordance, and give the word that we want to see in context, give the word as an argument to this concordance method. So we see that, for example, text 1 has word discover 7 times, and this is the word in context. So some words before this word and some words after this word. Or we can look at the inaugural speech corpus and look for concordance of the word nation. The word nation appears 330 times. NLTK is showing us the first 25 of them. Just so we can see how this word is used in a given text.
Sorry, a question. How can you change how many it shows?
How many it shows? Okay, I will show that shortly. You can ask for help of this concordance method. So just write help text 1 or text 4 dot concordance, and the help will tell you that this concordance method has 2 more parameters which you can skip because they have default values. One is the width of each line in characters, and the other one is the number of lines that get displayed. So you can supply the lines parameter like this, writing lines equals 30, for example, and you would get 30 matches. You could also write 330, but that would be quite a long list. But then you get all the matches. Thank you. Yeah. You can assign this. So one more thing. The concordance command prints concordances to the screen. But you may also want to store them in a variable. For that, we have another method called concordance list. It works similarly to the concordance, but it will not print this concordance list. It will save it to a variable it will return this concordance list. So, and let's see what's the type of concordance list. It's a list. And let's see what's the length of that concordance list. And the length is 25. Okay, that's maybe not that exciting, but let's say that we want many more lines. Lines equals 400. So we generate this concordance, and now its length should be, well, its length is 330. So we have got this whole list of concordances, all the mentions of the word nation in this text, and if necessary, we can also write them to a file. We can also look at some first concordances. This is more like service information, you could say. I won't go into detail of it. But if you have a concordance list and you want to print these concordances yourself from a list, you can write a cycle. So in your notebooks, you will also see a cycle for item in concordance. Let's slice the first 10 items in this concordance list. And then let's form a line, kind of reconstruct the concordance and print it. And here we have taken concordances from the and printed them on the screen. So that much about concordances. Are there any questions or issues? I hope you can follow along. That silence doesn't mean that you are lost. But if you get lost, then let us know.
Can you go once again over the step, what the second line?
What happens here? Okay, so we go through, I'll start with the first line, then I will follow to the second line. Here we take a slice of first 10 concordance objects from the concordance list that's stored in concordance variable. And in the for cycle, for each of the items in this slice of the list, we execute the next line, which constructs back this concordance string. It takes the left side before the word, adds the space to it, then it takes the actual query word that you looked for. Here it's nation, and then it takes the right-hand side that follows this word nation. So basically what it does, it retrieves the left-hand side, adds the space, adds the words that we are looking for, and adds the right-hand side of the context of this word. So we kind of repeat what the concordance program does, but we use concordance list information that we stored in variable conc. Well, we looked for word nation here when calling the concordance list method. We said that we are looking for word nation and we want 400 lines. Now you are asking, when did it became item.query? The first part, item, it's just the names that I chose here in the cycle. So in the for cycle is written for variable name in, and then a list of some objects, a list of concordances. And so for each object in this concordance list, the for cycle retrieves this object and it calls it item. And for the dot query part, we have to look at what this concordance line object contains. And somewhere in that object, we have information that the query which we asked the text corpus to find concordance for, that the query was nation. Does that answer your question?
But why did you call it item, not left like nation?
It's up to you how to name your variables. I just am used maybe writing for cycles for item in a list. But it doesn't matter if it's item or if it's something else. I could write line, for example, for line in...
Why can't we leave it a nation so that we can... Yeah.
It's because a nation is the string element. This is a variable. The function is variable. And we repeat them everywhere. But you can also call it a nation. It's just that the string you're looking for is the same as the variable you have named.
Thank you.
May I ask another question regarding byte? Because we were just playing around with the idea that we want to have more words or more sides on both sides, and we only found that it's possible to change it in one side. How to change it on both sides?
Oh, did it change on one side only?
Maybe because we did with 5 sides, and it always gives us an examples where nation is the last word. So maybe just too small number. It's with 20 change. Okay, with 20 changes. Sorry.
Okay. All right. So, well, at least what you saw there was printing concordance list and then storing this concordance list in a variable that we can work with later on. Okay, Divi, huh? And for those who had technical problems and could not run Google Colab at all, could you raise your hand who still has this problem? You have. Okay, and use over there. We have 2 computers which we can give you, and you can try running Google Colab on those. That's the best solution we can think of. So three people have an issue. Te ir pieejams laikam viens dators. Okay, so there are computers available to those who have issues running Google Colab. We hope that with another computer, library's computer, that it will work for you. If not, the best you can do is either install Google Colab, install Anaconda installation, or follow us just by reading this notebook on GitHub. So, while we are on this topic, any more questions? Now, what else can we do with this nltk.text object? We can print words that appear in similar context. So, for example, we are looking at text 4, inaugural text address text, and let's look for words in similar context as nation. And NLTK prints us a list of the words that appear in similar context, which are country, people, government, world, union, constitution, and so on.
What does that mean exactly in similar contexts?
Okay, let's see help for this method. Here it finds, as far as I know, it looks for words that have similar words around them. So that's the context. But I'm not an expert on this, so one solution could be, or answer to your question, would be to look in NLTK documentation, and we should be able to find just a moment. It was similar. Okay, well, it does not really explain this further, more than saying that it's distributional similarity. Find words that are in the same context. But it would...
May I ask, because I actually encountered this question during my study.
Okay.
Because maybe there are linguists who can help with exactly interpretation of this similarity or whatever. Because what we have here is a kind of list of words that are appearing in similar context. That's what I understand. But how far we can go and interpret them as, for example, pointing on some particular semantic field, or how, maybe that's not the problem for this workshop, but I think that's very important because one of the things that we pointed out in our first discussion was that there is a problem with interpretation. So maybe if there are some people in the audience that could help us naming this.
Okay, so about that common context thing, as I understand it from the output in the notebook. So, for example, we have that and then blank space. So that means that you can have a phrase that day and that night, and both of them sound fine. Then a very frequent collocation would be the previous day and also the previous night. So day and night are the words that are found in collocation with one and the same words. Does it make it clearer? Yes?
The question is, what it is in terms of sense?
So I would say that these words are found, so they are found in similar collocations. You could say that they are in the same semantic field, time of the day, for example. Yeah?
So we have to find the name of the field.
Yes. Yeah. But the problem could be that in a different context, day and night would not be members of the same semantic field, but they would probably be antonyms, for example. Or if it's very important in text analysis to separate the semantic field day and all the words related to day, and then all the words that are related to night, then those would be two separate semantic fields. But if we look at this common context, then from this point of view, we can deduce that they belong to the same semantic field, which is, for example, time of the day. That would be the interpretation, probably. Yeah?
Okay, thanks a lot. That we can really use advice and comments like this. And
Probably we should define the term collocation. Collocations, these are typical word combinations. You mentioned some actually, yeah, so that words which typically combine, yeah, and then they are Well, when we start speaking about semantic fields, that's already kind of a broader issue, yeah, because they can, of course, belong to different semantic fields depending on the context and so on. Yeah, but collocations, typical word combinations.
Okay.
In the given corpus, I must add. So words that appear together more frequently than by chance, and this is calculated mathematically. It's this every time you are looking for collocations, the algorithm calculates the unusually frequently words that are used together unusually frequently in this corpus, and this is your list of collocations. So the bigger is your corpus, the more interesting the results may appear.
Yeah, but that's exactly my question, because I'm coming from, okay, I have a background in linguistics, not linguistics, but Latin philology, but I'm working since 20 years in communication science. So for me, important thing is not to talk about linguistic phenomena, and even not to use probably proper linguistic terms, but to speak about sense. For example, if I have those collocations for, let's say, speeches of politicians on parliamentary corpus, how far can I go to say that, for example, this and this particular politician or these particular politicians are talking about the same thing, and that's this thing. So let's say day and night, that they are talking about the daytime here. You understand what I mean? So because there are several layers what are in play here. One is this mathematic or statistical or whatever calculation. Another is linguistic level of different linguistic or language phenomena. And the next level is when we talk about not only meaning but sense of in the communication situations. So I think that's maybe a little bit. Maybe we can.
It is fascinating. So I feel that there is room for this continuation of this discussion, but we have to go through the exercises. So what we do here is exercising our programming, coding skills. So it's natural that we have broader questions in mind while doing that.
Mm-hmm. Okay, so let's continue, but it's good to have a discussion like this as well. And we can also use the method called common contexts, which will find for a list of given words, it will find the contexts common to them, so collocations in which they appear. And these are, this is a list of different contexts. For example, the previous day, the previous night, or the day before, the night before, every night, every day, and so on. We can also ask for help on this common contexts method, although that help will not tell us much more. It just says find contexts where the specified words appear. But okay, that's one thing that we can look at. Next, we can look for collocations in this corpus, and to do that, we call the collocations method. Say that we are interested in collocations of two words, and we're interested in 40 results. So we get pairs of words that appear more frequently in this text, word combinations such as United States, fellow citizens, years ago, and so on. Yes?
The window size, it's a command to search these two words. Is it like it's always, if I want to find like 2, 3, or 10 words, should I always write window size?
For that we can look at help for this method, We can see that indeed there is a window size parameter, which by default is 2. So in this case, we could have skipped this parameter. But if you want to look for collocations of 3 words or more words, then you have to write this parameter window size equals and the number of words that we are interested in. For example, we can look for text collocations with window size 3 and Yes, that's a good question to look at it later on, because it looks like even though I supplied window size equals 3, it did not look for collocations of 3 words. So that's something to look at during the work session then. Now, NLTK text is also a list, so we can do list operations on this NLTK text. For example, we can look for the first occurrence of the word he in this text, and the index method returns the value 42. So word at position 42 is he, and we can look for a sentence that this word is a part of. Now, this was just a quick crash course in the NLTK text object. We can do more with it. We can do some visualizations as well. So dispersion plot will show us where in the text appear certain words. So how frequently they appear, for example, in this inaugural address corpus, where there are inaugural addresses from various presidents. And the corpus is sorted chronologically, so we can see when words like citizens, democracy, duty, freedom, America appear in this text. And we can see that America appears quite frequently throughout the whole text. X-axis is word offset here, but word freedom appears towards the end of the corpus. Duty is more apparent in the beginning of the corpus, and democracy and citizens towards the end of the corpus as well. Again, we can ask for help on dispersion plot, and even though that help is very short, it tells us that it produces a plot showing the distribution of words in this text. We can also plot word frequency using the command .plot, and it will provide us with a line graph like this. Underneath the hood, this plot command uses the matplotlib library, which we will look at as well, time permitting. We can convert this text to a list and take a slice of that list. And now we may want to clean this text a bit to get maybe more interesting frequency plot. So we may want to remove punctuation like comma or dot, and we might want to remove stop words. So these are words that appear in the text so frequently and that are so simple that they don't really carry much meaning. So words like and, to, in, and so on. So let's now see how we can filter this text, clean it up a bit, and let's look at word frequency distribution again. So in order to, well, one thing we can do, we might look for tokens that are words. That is, tokens that consist of alphabetic characters only. And to do that, we use a Python construct called list comprehension, where it's written so that we are looking for items of a sequence, text 4. So we're looking for all the tokens in this text. Let's call these tokens an item. So we go in a for cycle through all the items in text 4. And we will save or keep only those items which are contain alphabetical characters. So this should skip things like a dash or dot or commas. So we have filtered some text out. This would also filter out items containing digits. So if you want to have years or some other information like that, then you might need to modify this command. But basically, this command allows you to keep alphabetical letters, so to keep words. Now we need to filter out stop words. And for that, we first need to import stop words from the NLTK corpus. These will be stop words in some popular languages, such as English, probably French, and so on. If you are interested to find out more what languages it supports, you can look for help, which will lead us to NLTK documentation, and there we can look for information about languages that the stop words module supports. But I don't see the answer right away. In this notebook, we will use stop words for English, so that should not be a problem. So we import these stop words, and we can look at the content of stop words. It's just a list with words like I, me, my, myself, and so on. And now let's filter out stop words. We will use this list comprehension again. So for item in filtered list, so the list that we made, word list that we made before, let's keep only those items that don't appear in the list of stop words. So we will get a list of words here, like fellow, citizens, Senate, House, representatives, among, incident, and so on. And now when we have a cleaned up list of words, we can, for example, plot word frequency distribution. So we take a list of words and we construct NLTK text object based on this list of filtered words. And then we use the method .plot to visualize this word frequency distribution. Now, how is everyone doing? Are there any questions, anything that you need?
I've noticed that the concordance, or at least the program, does discriminate between the same words who are in smaller caps and those whose first letter is capitalized.
Okay.
So I'm wondering if there is a way how we can make all the words in whether we can make it so that the program understands the words in small letters and the ones whose first letter is capitalized as the same thing, since it's the same word.
Okay, so the question is about the concordance and the fact that it discriminates between words with capital letters, say starting capital letter, and words with lowercase letters. That when you look for concordance of these words, these are considered different words if it starts with a capital letter or with a small letter. And how to solve this? The easiest thing to do would be to convert all your text to lowercase. Yes, you lose information on what was in uppercase or lowercase, but in that situation, you should be able to find all, they will be together, what was in lowercase and what was in uppercase. So I would just convert the text before even creating this NLTK text object. I would convert the text to lowercase. That's probably the easiest thing we can do.
Did we discuss how to convert text to lowercase in the previous lecture?
Well, I showed an example, but it can be a good thing to come back to it. Let me think, where can I show it? So there can be two cases when we start from a text, such as excerpt here. I will create a new cell here, and so when we start with a text, we can convert the text to lowercase by calling method dot lower on a text string. So you call a method dot lower, and it converts all the text to lowercase. That's a situation when you have the whole text that you can run this lower operation on. So, well, that's a solution or one of the solutions. Then you can feed it to NLTK text like you did before and work with it that way. Now, if we have a list of words like we are working with here, we can also convert words that appear in a list of words. We can convert them to lowercase, but in that case, so words lowercase. In that case, we will need to use this text comprehension, list comprehension, like this. So we take a list of words in the list called filtered. We look for item for every item in this list, and we convert that item to lowercase. So that is another way how you can lowercase text. So in one case we had text to work with. In another case we had a list to work with. Does that answer your question?
Yes, thank you.
Okay, thanks. All right. And now let's plot word frequency distribution again, based on this filtered text. So now it probably is more interesting. We see words like people, government, states, country, and so on. So that's a word frequency plot, which counts how many times a given word appears in the text corpus. So it should give us some sense of what this text is about. We can ask for help on frequency dist.plot method. And the reason why I show help for this function is that you can have some additional parameters that you supply to this plot method. Now, frequency distribution counts the number of times that each token appears in the text. And this frequency distribution object, as it's called in Python, has some methods or some actions that you can run on them. Now, we did not look at objects yesterday. It would have been even longer if we looked at object-oriented programming. But for now, it's sufficient to know that we can create frequency distributions from some text, and we can run some commands on these frequency distributions. So we create frequency distribution like that. We should have imported this freqdist object from NLTK library. Once we have done that, we can just write freqdist and give it some text. And now we have information that word people appeared 589 times, the word must 373 times, and so on. And now we can look, we can, of course, print this frequency distribution. We can look for the max value, so the word that is the most frequent. We can look for frequency of certain words. For that, we write fdist variable name, where we store this frequency distribution, dot freq, frequency. And in brackets, or parentheses, is it? In parentheses, we put the words that we are interested in. So we can get percentage of what percentage of the document consists of word people, and it's 0.8% in inaugural corpus. Or we can also look, so one option is to look at the percentage, the other one is to look at absolute numbers, how many times a certain word appeared in this text. For example, let's look for words government and people. In this print command, we access the number of times the word government has been mentioned by writing fdist variable name, and then in square brackets, we have the words that we are interested in. So we now know that the word people appeared 589 times, and the word government appeared 334 times. Just in uppercase, that's true. We did not normalize the case. And I could have used the result of lowercasing the text and got government in both uppercase and lowercase. That's a valid point. Here it's in uppercase.
What does the command bprint, how does it differ from just print? Like we sometimes put print in the front, but here it's bprint at the back.
Okay, well, the difference how they are used are due to the fact that print is a function that is already available from Python, and the function is called by putting it in front, like you noticed. And pprint is called a method of this fdist object and that's why it's written after the variable name. So they are different things in Python that get called different ways. I won't go into further detail on object-oriented programming, but so let's keep in mind that when we use print, we write print first, and then give it a parameter. And for pprint, it's a property of this particular frequency distribution object. So it's called after the variable name.
But the result is the same if we get, like
The result is not actually the same. If you print this fdist, it prints you this information here, that it's freqdist with 70,000 words and about 10,000 unique words. It doesn't list you. So this is a situation. In some cases, print and pprint would be similar, but in this case, print doesn't show you the actual frequencies, and pprint shows you these frequencies. But you can also print these frequencies for yourself, and I have just an example for that. So to print these word frequencies yourself, we will use a for cycle. So let's get, we will use the method .mostCommon, so another action that we can perform on word frequency objects, and we'll ask for 40 most common words. And then we will store that in a variable most common, and then we will use for cycle to go through this list of 40 most common words, and we will print the word and the value. And this is what it will look like. And indeed, government appears in uppercase and in lowercase, and we may want to sum those together. So that's how we can print these word frequencies. And of course, we could also save them to file. We could save them to a file and then work with them further in some other case.
the padding shows us that we're only looking for words that are shorter than 14 characters.
Okay, just a moment, it's loading again. Yes, you notice that I am using padding here. Yes, I used padding for 14 characters, thinking that probably the words that we have will not be longer than 14. But if there is some words that is longer than 14, that's not a problem. It will just make the line longer. I use special syntax for this padding. I could have put padding 8 as well and see if the word is longer, it's still printed, it just takes more space.
So it's a matter of aesthetics, basically.
It's a matter of aesthetics here, yes. Now, there is some more information about working with word frequency distributions and cleaning the text corpus in Day 2 NLTK bonus notebook. So there's another notebook that we won't look at right now, but you can explore it on your own. And let's quickly, are there any more questions? No. Oh, okay. Let's look at how we can work with our own text. And here we will look at text that is comma separated or tab separated values. So it's a corpus of old newspapers, newspaper articles in English, and it is available as a file online. So we will not need to read the file locally. we will read the file from a GitHub repository. And this file is tab separated. That means that, well, it's basically a table which consists of columns and lines. And in each line, table cells, you can think of it like an Excel table. Table cells are separated using the special character called tabulation character, or tab separated values. That's what this .tsv indicate. And let's take a URL, a web address, and let's use the pandas library command read CSV. This pandas library knows how to read these comma-separated values, or in this case, tab-separated value files. We give this command either a file name or a web address. In this case, we'll use web address. And we also will tell this command that cells in this file are separated using this special tabulation character, \t. Let's read the file and see what we have got. So by calling a property df.shape, we can see that our dataset consists of approximately 5,000 rows and 5 columns. And let's print, use the command .head to print the first 10 rows. And this is what our dataset looks like. So it contains of 5 columns called source, which can be LA Times, NJ.com, Chicago Tribune, and so on. Then we have the date, the type, subjects. So there is some subject information. I don't know more about that column. And there is the text column, which we are interested in. So we want to do something with these texts. First, let us sort this data set by date. To do that, we can call the method or an action on this data frame variable called sort values. And we will tell it to sort values by date, by the date column, so by this column, and to sort them in ascending order. And now we see that the first texts that we have are from February 2005. Now let's get the documents out of this data frame, this pandas data structure. So we write df.text. That will return us just the text column. And we convert it to a list. So we end up with a list of texts that consists of approximately 5,000 text fragments. The type of the document's variable, what the document variable contains, is a list. We can look at the first 3 documents in this example. Some are longer, some are shorter. We can look at document number 2, well, document with index 1, and that's the document that we can work with. For the purpose of this demo, I will combine all the documents together into one large document. The len gives us the length of some value that's stored inside a variable in this case. So the len tells us that it tells us the number of characters in this case. So it's the length of the value stored in all docs variable. So it's approximately 1 million characters. And now we can use this text to tokenize it into words, into tokens. But before we do tokenization, we convert this text to lowercase. So, just your question. We will convert it to lowercase. We will tokenize this text, and then we will feed tokens to this nltk.text object. And let's see what we've got. So the type of text is nltk.text, and we can look for concordance of a word. For example, the word million appeared 169 times, and here we see this word in its context.
So moving from the so words to NLTK text it's like moving from one format to another.
Yes, yes, we are converting a list of tokens to an nltk.text object, on which we can run concordance, collocation, and other actions. Now we should finish this.
Exactly. I had this important announcement that the lunchtime has arrived. So Uldis can maybe finish the sentence or the paragraph, and then I wish everybody has an hour break. If you haven't had the coupon for lunch, you can still get it at registration table, and we meet exactly at 2. Uldis?
Okay, thank you. Well, I just showed that we can look into the text using the tools that we learned in this lesson or in this part of the workshop. And at that, I will stop and let's have lunch.